In this video, we are going to study definition of random variable and its types with the equations. So let us start with the definition. A random variable is defined on a sample space and it takes values from the sample space. So it is denoted by capital X. Now see the definition of this random variable. So it is a variable which is defined on a sample space. So sample space is created once we have an event. So each and every possible outcome of a event is nothing but our sample space. So we are defining a new function which is denoted by capital X, and this X will take only certain values from a sample space which will be defined by the condition of the random variable. So we'll see example, then this definition will be more clear. So remember here the another important concept of this random variable. So random variable is not random. Because it takes finite values from sample space. Though the name of this variable is random variable, it doesn't take random values. It has fixed values, finite values, which are defined in the sample space. Now let us take a simple example. So let us say two coins are tossed simultaneously. Here a random variable takes values of the number of tails in each outcome. So let us see how to find out this random variable. So here we have a event, two coins are tossed. So first of all, find out the sample space. So as we have two coins, either we will have both heads, one head, one tail, first tail, second head, and both tails. This will be our sample space. Now we need to define a random variable. So random variable, which is denoted by capital X, is equal to, it is the number of tails in each outcome. So now here what we are doing is we are defining a new function X over a sample space. So this is our sample space, and on this sample space we are defining a function X which is called as random variable, which takes the values which is equal to number of tails in each outcome. So if you look at the sample space, if you look at the first outcome, head, so here number of tails are 0. So this capital X, which is random variable, will have the first value as there is no tail in the outcome. If you look at the next two outcomes from the sample space, here we have one tail. So the second value can be x1, which defines or which indicates there is only one tail in the outcome. And lastly we have tail, so it defines that the random variable can have two tails in the outcome, so it is defined by x2. So these are the functions of x0, x1, x2 are the values of x, where x0 indicates there is no tail in the outcome, x1 indicates there is one tail, x2 indicates there are two tails in the outcomes. And now we are supposed to find out the probabilities of these events. So here, probability of this random variable taking value as x0 will be equal to, so x0 means what? We don't have any tail in the outcome. So how many outcomes we have in the sample space which we do not have the tail? It is single outcome divided by total number of outcomes are 4. Similarly, probability of x taking value as x1, so total outcome in the sample space which have single tail are 2 by 4, which is nothing but 1 by 2. And finally, the random variable takes value as x2 means it has two tails, so the probability is 1 by 4. So in this way we can define a random variable capital X which is taking the value of number of tails in the outcome from the sample space. This is simple random variable. Now let us classify the random variables. So here, types of random variables. So we have two types of random variables. First is discrete random variable. So this random variable can be written shortly as RV. So discrete random variable, and second continuous random variable. So simple definition for this discrete random variable is that it takes only discrete values. And continuous random variable, it can take any value. So this is simple definition for this random variable. So here we have seen the definition of random variable, how to define a random variable from a sample space, and the types of random variables.